Hello everybody, today we are going to implement a state machine. State machines are a wonderful little code pattern that allow us to contain a lot of complexity and abstract it away and do what we want things to do when we tell them what we want them to do. We're going to be using it for our user interface in this project. I've basically finished up. It just needs a little bit of UI polish. And yeah, it's pretty great. So what we're going to do is we're going to say, all right, I have some set of states, call them states, some conditions that need different game objects enabled, different menus open, different background music playing, different sounds playing, different behavior going on. But I can roughly categorize them into these different states. Main menu, heads up display, pause menu, game over menu. And I need to transition between them. To have an object turn on and off all of these different game objects that are, UI panels that have the different menus in them would be kind of a pain. It'd be like, okay, so the player's dead, then we should turn on the game over screen. Unless we're starting a new game, then we turn that off and then turn on the heads up display. It gets you get this giant if-else chain. And we can just clean up that giant if-else chain by using a state machine instead. All right, so it's time to write some code. Let's get into it. Let's show you how it works and what it is. No, we don't do that. We start with a plan. Here's the plan. I already wrote it out. So we have a machine, which we're going to have a class. We're probably just going to call it machine or state machine. And it gets told commands, hey, go to some state. That's what it gets told. That's the type of information it will receive. Then it will do just that. We'll have a separate object for the different states, separate class, that will themselves have a list of game objects that they can turn on and off, or have events they can fire and enable and disable, and so on. So we're going to use a nifty interface to deal with that, a state listener, something like that. And that's the plan. We're only going to be turning on and off game objects, but I'll show you the interface part anyway. So let's get started. I want to keep this video short. I'm going to try to keep this video short, but I still need to show you the project as it exists. There's a fun iOS game called Hoplite, Hoplite. You should go get it. You should go play it. It's a really fun game. I've made a clone of it. You have this hexagonal grid. You have these AI that take their turn. You take your turn, and they move. Oh no! What? Link errors. I'm not going to worry about that. I am using I just changed the AI a bit to do it didn't have any valid destinations, and it tried to sort or order them by which one was like closest to the player, but there weren't any there because it was all blocked by other AI. I'll fix that. Not important. Not what we're doing today. Okay, so we need when you die, let me make it so you don't have like 1,000 lives. Starting health, how about 2, 1. When you die right now, well, here you go. You go to a shop, you can buy things. So that opens up a menu. I already kind of have that code. It's really messy. I just got hit. I died. I have no health. What do? I need some game over state. That doesn't exist. I can push R on the keyboard. I wrote a little debug script. So we got a UI, we got heads up display, we got a store, we need new game and game over. So let's get started with our code. I'm going to make a new folder. I'm going to call it state machine. I like to keep things nice and organized. But let's head into Writer. And let's make the Unity script. Let's make a mono behavior. Let's call it state machine. I'm in a GitHub project. Okay. That's big. So the state machine, we made a namespace. Writer picked up on the folder structure to automatically give me these namespaces. So like all my managers are in a manager's namespace. Sometimes I like it, sometimes I hate it. I just work with it because it's the way Writer is set up, and I'm too lazy to go in and like fine tune it. But here's our machine. It will keep track of the current state, and it will go to states. So how are we going to store a state? Good question. we are going to store, I mean, there's different ways to do it. One, we could just use an enum. We could just use an enum and then have a dictionary of listeners that belong to that enum, or enums that map to the listener. Yeah, that's kind of confusing. It is kind of confusing. So we're gonna put the listeners in a separate class and make a machine for it, but we're still gonna use an enum to identify them. Hello. This is not a great way to do this long term using enums. Got to keep going in here and adding to them. I would use a scriptable objects, but I'm trying to keep things as simple as possible. Maybe I should just do scriptable objects. Maybe I should just do it the right way, because this is a video showing you how to do things the right way. Okay, our state is actually going to be a scriptable object. Lovely. And we need that, what is that, context menu item? Name is that context menu item? What is that? Where's my, okay, here. I'm going to show you a writer tool. A writer quality of life feature. If we can make a scriptable object, call that state. And it's, it gave me the asset menu. I forgot. Gotta get you. Okay, we'll call this state menu name state. Okay, and that's got an on-enter and an on-exit function. We're doing it right. We're not going to use an enum. Not going to trip ourselves up. All right, so we need public state for our default state, our starting state, and a public void go to state. New state. I'm just gonna go to, yeah, there you go. Private state, current state. We need to keep track of what state we have. There are a lot of different. What do you want? What do you want, writer? What are your initialized? Don't want to do that. So we'll take the current state. If current state is not null. Okay. So when we go to a new state, oh my gosh, what are these? First, we will take the current state and we'll run onExit on it. So whatever the state does, it knows that it is no longer going to be the current state, but it gets that onExit call. Then we're going to set current state to be the new state we were told, and new state dot on enter. And that is the core of a state machine. Is I am keeping track of this one, whichever one of you is like active. Whenever I deactivate one, on exit, on enter, we bring in the new one. And that's the core, that's the meat and potatoes of a state machine. One nifty thing you can do is store this as a list and then add it to the top. And then you can have states that like leave their current state without being told to go to a new one. You're just told this one's leaving, and it will just default to the previous state. And that's sometimes really important. You can open a pause menu, you can just close the pause menu, and it'll just go back to where it was before. I don't think we need to do that. We're not going to worry about it, about that level of complexity and support in this simple machine. But we have a function, go to this state, and then do that. So how can we make these onEnter and onExit functions useful? Well, we could do something like a unity event. Public unity event on enter event, public unity event on exit event on enter event dot invoke on exit event dot invoke. And now that we have these unity events, let's make a folder for our UI states, and let's make a state for main menu. Now we have that little scriptable object, main menu state, and it's got a unity event for onEnter, and we can call some function and onExit. Problem is, we've made these as scriptable objects, which means they cannot have scene references. They cannot have a reference to a specific scene, and that's bad. So we need some way to get a game object in the world to listen to a state. So we're going to make, to use that, we're going to do an interface. And we're going to apply that interface to any game object that will have a, that will listen to for an on-enter state and an on-exit state. And we're going to call that a state listener interface. State listener. State listener. So state listeners, it's an interface. We're not actually going to implement any of the code in this function. We're just going to, we're going to tell the state that whatever has this, no matter what, it must have an on-enter, we'll call this on-enter state and on-exit state. Maybe I don't want to call it that. Maybe I just want to call it that. And that's our list. That's whatever, we just have to implement that. Then we're going to keep, we can keep these events here, but I'm gonna just try to keep the code nice and clean. You might still want to have those types of things around, but we're gonna have a list of listeners. And we need to import our collections to get our list. State listener will be our listeners. We'll initialize that. We're in a scriptable object, so we don't have these awake events, right? So we just need to be wary of that. Void add listener state listener new listener, and we'll add a function to remove it. I'll write that code in just a second, but first we'll do the on it to show you what I'm actually doing here. For each listener in listeners, we will call these on-enter and on-exit functions. Just like that. Pretty nifty, right? So we'll have our listeners. And then when we enter, we'll tell all of our listeners that we have entered. And when we exit, we will tell all of our listeners that we have exited. You might not want to do a for each loop. You might want to do like a for loop. You might want to do a for loop that loops not from 0 to the count, but from the count down to 0, I minus minus. It goes the opposite way. That way, a listener could remove itself from a state while it's like as it exits. It could just be like a 1. We're not going to worry about that. But if it could change the size of if this list could change size because of these functions, then we shouldn't use a for each loop because that'll throw an error. I don't think that's going to happen. So listeners.add new listener, listeners.remove. So let's make an actual object that will be a listener. And that object is going to be, let's call this active with state. So we need a state, state. And then we are going to implement that state listener. Writer has an error. It says you haven't implemented it. You've broken the promise that the interface is making you promise that you need these functions because it's going to try to call them. They don't exist right now. That's an error. We'll let writer generate it for us. So we'll implement those functions, the ones of the listener. And then on enter, we'll do game object.setActive true. And on exit, we'll do game exit.setActive false. And void awake. We need to register ourselves, state.add listener this. And destroy state dot remove listener. This. So, tricky thing is that these states are scriptable objects, which means they're not going to get reset or changed. They're going to have these listeners as we go from scene to scene to scene. So this object could get destroyed when we like unload or go to a new scene or for some other reason, and a different state needs to, and then the state's going to like do an on exit or something, and it's going to say, hey, listeners, check yourself before you wreck yourself. And it's going to be null. We're going to get a null reference exception. So because of this, we're using the scriptable objects. We really want to be sure that we're, you know, if listener is not null. I mean, we can be lazy about it, but I don't want that code in here. I want to get the error. I want to see when that error is happening. But that's the type of thing you want to be aware of when you're using mono behaviors and scriptable objects that have references to each other. Is those mono behaviors or normal components, their lifetime and how they behave is different than the state machine references, not the state machine references, the scriptable object references, and that can trip us up. Okay, so state machine, default state, but that is a mono behavior, right? Void awake, default state. That we'll go to state, default state. Okay. If default state is not null, then we'll go to we'll do that start. We'll let other objects initialize and add themselves as listeners. Where am I? Where's my active with state? Right. It's going to add itself on awake, and then in start after awake, we'll actually do the thing. Watch out for that initialization. Okay. Is that everything we need? Maybe. I think it's enough to start trying something. Let's go to our canvas. And let's make a new, let's just do it. Let's put the state machine right on the canvas. That's like a pretty good place. State machine, I'm gonna call it UI canvas. My states, I've got a main menu state. I'm gonna duplicate that. I'm gonna rename it to shop display. I'm gonna duplicate it and rename it to game over. What was the other states I need? I don't know, we'll figure it out. We can add as many and remove as many as we want, whenever we want, because that's the beauty of the state machine. We're not hard-coded to these enums or hard-coded to these giant if-else branching trees. We can just, you know, it can just be whatever. Oh yeah, we need a gameplay one, don't we? Gameplay, duplicate, rename it, gameplay. So we'll take the heads-up display and we will give that active with gameplay. We'll take the shop and we'll make that active with shop. And let's just try the default state as gameplay. And then we're gonna do one more thing. Our active with states, we probably want this to be, we probably want them all to default to deactivated. Maybe we don't want to do that, because that's going to get called on start. So that's going to be, it's going to be awake and then start. Yeah, that should be fine. We might want to add a is current state boolean to the state object, that we could do those kinds of if it's the current state already, you know. Cool. So my shop is deactivated and my heads up display is activated. I haven't removed any of the other code to it. So we should probably go and put this in the rest of our project so we can start using it. Private state, game over state. And then where does our player die? They die when a new turn has begun, but they are dead. Game over, state machine, UI state machine dot go to state, game over state. And then I guess on start. The default state is already called by the state machine, so that's going to turn on something. But maybe on maybe we got to go to the gameplay state when we're on a new game. State UI state machine dot go to state gameplay state. It goes to the gameplay state. We're going to need a reference to that too. So if it defaults to the main menu, and then we'll say, okay, we started the game, go to the gameplay state, bring up the heads-up display. But don't show the heads-up display on the main menu. We don't have a gameplay state. We don't have a main menu right now, but that'll be the default state. When we begin a new game, it'll go to that one. Okay, new level. Okay, so now we got to go do the shop stuff. Where is the shop? Which thing was null? All right, we're pausing the video, debugging. Unpausing the video briefly to say that the hubris I had of implementing the fix and then unpausing the video before testing it. Well, I flew too close to the sun. All right, I hit an interesting point, which is the shop menu opens. It opens it up. My bug fix was that I had my previous logic that was enabling and disabling it before any of the state listener object even got like started. Because when the game object's deactivated, it doesn't get those awake and start events. So one component got the awake event to deactivate. The other one never got the awake event to register the state stuff. Not important. But I just hadn't finished replacing the old code with the new code. So bugs, obviously. But what's interesting is I had mentioned earlier about a state machine wanting to be a list, and then you could have states leave their current state and just default to whatever the previous state was without having to know the previous state. And I said, we don't need that bit of complexity. It's not important right now. Well, here I am in the UI for when a button is pressed that gives you your, the item that you've chosen from the shop, and it deactivates the shop so it can't be, you can only use it once per level. And then it needs to leave the current state and go back to gameplay state. But I don't want to hold a reference to what the gameplay state is in like the shop. That's like not where that logic should be held. So I'm going to the game manager and I'm like, okay, well, why don't I get the current, the state machine, which is that getter from earlier. Now we have a public reference to it. And now I can tell it to go to, gameplay, right? But I don't want to hold that reference here. So I'm just going to write go return to gameplay for shop purchasing complete. And then we can do the go to state gameplay state. All right, and we can put that logic at least somewhere somewhat reasonable with functions that are named in like an identifiable way. So even though we have this like architecturally ugly thing where the shop needs to like know about things that are not the shop in order to like go back to what those things are, regular gameplay, at least we can move them around to a place that's like somewhat reasonable. Here is exactly the use case for take the current state, just leave this state. Just leave the state. I don't know what you're going to do. Just exit this state and go to the previous one. So in the machine, we would have a list. It would be we would inject into the state a reference to the machine, and then we would have the state have a leave this state function, which would take that reference to the machine and call it, and it would pop the current state off the top of the list if it had one below it, and then go to either a default state or the previous one, and it would keep adding them to a list. I still don't want to do it because, I guess now I do want to do it, but we're not going to because I don't have time. Let's just see that code works. I've added code without testing again. Let's go to the shop. Let's buy a health upgrade, and now we can continue. The UI appears. Go to the shop. Well, we can't because let's restart the game. Hey, I'm next to the shop. We'll go to the shop. UI hides because it's not there in the shop state. And now we have an upgrade. Okay. Cool. Okay, so let's make a game over function. Let's make a new UI panel. call this game over. Good enough for game jam, I think. Okay, it bothers me that that is so low. Okay. And now, all we need to do in order to add all this functionality is to add an active with state component and add the game over state. And then let's check our game manager that we go to the on game over. We go to the game over state. And then a new level, we will, or a new world, new game, we will go to the gameplay state. Because that button should unclick. It should reference our game manager. I should tell it to do new game, new game. So it's, I gave myself a lot of health because I was testing. I didn't want to actually play the game. Let's lose. Okay, we'll go into the archer, and they'll kill us, and then they'll kill us. Game over. Just appeared. Restart game. I still don't have health. Oh no, I know what happened. The UI didn't update when I restarted the game. Restart game. That's solvable. It's 2, but the UI hasn't updated. Because when you got hit, it went to 1. Why didn't the UI update? Because it's not activated. Because it's not activated when it's receiving the event. So we will go to our game manager and change the order of that. Something like that. What's the state? That's a different thing, right? No, it isn't. It's a game state. I have something else called state. That's confusing. That's why we use namespaces. Okay. Game state is what I call the thing that keeps track of like what level you're at and what the current difficulty is for a roguelike. And there we go. Fixed it. Okay. So let's talk a little bit more about those interfaces, those state listener interfaces, because I have 3. That's right. I added one when you weren't looking, when I paused the video. We have activating and deactivating objects with the state, which is kind of iffy. Maybe you want to just activate all your children objects and deactivate all your children objects. Let's make a new script for events with state. I just made this script from the Unity menu, so I have to make sure I am in the right namespace, right? I'm in a state machine namespace. Namespace, state machine. But no, we want it to be a mono behavior and a state listener. And implement those things. And then this is literally the code I showed you from earlier. Event on enter state. Unity event on enter event on exit event. So I fill private state and states. And then void awake, we will state.add listener this. Void on destroy. State.remove listener this. That's some repeat functionality. That's some repetitive code. Maybe we don't want to use an interface. Maybe we want to use an abstract class or no, just a regular class. And then we want to override the onEnter and onExit states. I don't, because I want also scriptable objects as well as mono behaviors. But I could write 2. I could have the interface and have those classes and just make my life easier. Those should be public. Or they should be serialized. Public. Yeah, public's fine. Oops, opened up the thing. Unity. So now if I wanted if I wanted some audio manager, audio source. God, on death sound. I don't know, whatever. Events with state. We would have a state for game over. You'd say, okay, on game over, I'm going to play the audio source stop. Play. So now, whenever that state, we go to that state, we can play a little, game over, play a little noise. I don't have any audio files on hand to like demonstrate that, so maybe a bad example, but particle effect or whatever. So that's the convenience, is we can just, you know, make these little events and we just run them. That's it. That's a simple state machine. That's dead simple. This video is at 40 minutes. Oy, I wanted to hit this in 30. Oh well. I hope you enjoyed it. Hope it was helpful. I have a state machine that I have up on GitHub that I've been using for almost all of my UI stuff. It has like transition events that keep track of things that are true or false, to then automatically enter and leave the states for you. So all my players have like a death condition, and they'll die or not die or whatever. It's just be like, have you collected everything? Yes. It'll just go to the next state. It'll do those conditional checks, which is a nice to have. Yeah, I did it. Yay. Anyway, go play Hoplite. It's a pretty good game on the iOS.